Earth, Environment and Society, an overview. Today we're having an excellent and very eminent speaker, Dr. S. Sri Kumar, Director, Integrated Rural Technology Center, Palakkad. And he's also a retired professor in geology, former HOD of Rice College in Galakuda, Department of Geology. And today he is being with us. I welcome you, sir, to this program. And also, I welcome Dr. B.K. Purandara. He is also a keynote speaker of our national webinar series. I welcome you, sir, to this program. And next, I would like to welcome Dr. N. Manoharan, who is also a keynote speaker of our national webinar series. I welcome you, sir, to this program. And I welcome all the participants to this special day of our program. And next, I would like to welcome Kavya B. Krishna, Assistant Professor in Geology, the Research Science College, to introducing the speaker to the participants. Thank you.
Thank you, Rahman sir. I hope I'm audible to everyone.
Yeah, please.
Yes, you're audible.
Thank you. Thank you, sir. A warm good morning to all of you. It gives me immense pleasure and pride to welcome you all to the fifth day of our national webinar series, Earth, Environment and Society, an Overview. Today, being October 2nd, let us remember the Mahatma who shook the world in a gentle way. And according to him, where there is love, there is life. A man is the sum of his actions, of what he has done, and of what he can do. May the spirit of truth and non-violence be with us during this Gandhi Jayanti. My Gandhi Jayanti wishes to each and every one of you. Moving on to my duty of introducing today's speaker, Dr. S. Sri Kumar. May I you? So, Dr. S. Sri Kumar is currently the Director of Integrated Rural Technology Center at Palakkad. He will be dealing with the topic resilience and sustainability in management of the smoke failures in hill ranges of Kerala. His areas of interest include environment and related studies. He had been a resource person for UNDP, Government of India, and a coordinator for disaster management under University Grants Commission in the past. He has authored several articles, books, and research publications, as well as made several presentations in his area of expertise. He has been a recipient of several prestigious awards and has also held the position of a member in several governmental and academic bodies for years. On this occasion, I am glad to inform you all that Sri Kumar sir is associating with our institution in the mega project proposal being submitted to the Department of Science and Technology, Government of India on landslides in collaboration with the CSIR NGRI, Guwahati University, Assam Downtown University, CSIR NEAST Jorhat, Dibrugarh University, and Kyushu University in Japan, under the guidance and support of our academic director, Dr. B.G. Unni sir, and active involvement of Dr. Gopalakrishnan sir. With lot of respect, I invite Sri Kumar sir to start today's session. Welcome, sir.
Okay. Thank you, Kavya Balakrishnan, for a nice introduction. I know that it is as our nation is concerned, it's a very good day to talk about the environment, particularly natural disasters, and how you can mitigate the effect of these kind of disasters by protecting our environment. And At the outset, I have to thank many people here and my dear Balakrishnan sir and Dr. Abdul Rahman, Dr. Naveen, Dr. Manoharan, Dr. Purandara, and Dr. B.G. Unni, the director of the academic session there, the principal of the college, and all the viewers here participating in the webinar. And I'm so happy to share some of my views with regard to the landslide. I'm not going much deep into the landslide, its mechanism and other things, but as a geologist, what we have to know about the measures to protect or mitigate the effect of the landslides and slope failures. And I never use the term landslide because I call the topic is related to slope failures, because landslide is we are referring to a particular event that is taking place as a result of the gap. And let me share my presentation. Okay, can you see?
Okay. Okay, sir. Okay.
So this is our topic: resilience and sustainability in management of slope failures in hill ranges of Kerala. You know, this is the background. You can see the major landslip that occurred in Kavalapara near Nilampur, and may be considered as one of the major casualties caused by this kind of landslip occurred in that area. And if you take the disasters in India, if you look at the severity of the disasters, you can see that we have got 5,700 kilometer long coastline, and the coastline is now vulnerable to different kinds of cyclones, storm surges, and inundation and these type of things. Then you can see 40 million hectares of the land in India is prone to flood. And also, when we talk about the flood, on the other side, we have the drought. 68% of the net zone area in different parts prone to drought. And if you consider the seismicity of the Indian subcontinent, you can see that 55% of the area is coming under the zone 3, 4, and 5. That is, you can see the magnitude ranges from 6 to or more than 6 in 55% of the area. Then we have the another natural disaster that is happening. One is in the sub-Himalayan region, and other one is in the Western Ghats, mostly. We call the landslides and debris flows, or whatever the different type of slope failures. So if you look at the Indian subcontinent, you can see we are vulnerable to different kinds of natural disasters. It is multi-hazardous, you can see. And if you take the anatomy of the slope failure conditions, you can see, we are studying from the degree level onwards. What is mass wasting process? That is the term that we hear in the physical geology and geomorphology and all these things. And you see that this is the movement of the material downwards because of the gravitational force, nothing more than that. And you can see how the material is moving downwards. You can see that it is detached from the top part of the hillock, and then sometimes it is moving very fast, sometimes it is moving very slow. Number of cracks are developed, and that's why we are saying that the cracks are indicators of major landslides sometimes. I can show you some of the slides where we can see that the cracks have been developed, or some kind of slab cracks have been formed. And these are all indication of a major landslide that can happen there. Or we call that one as an aborted landslide. Because if the environment is conducive, that can become a bigger landslide, can grow into a bigger landslide, and it can cause greater damage to the life and property. And you see that this material from the crown, that is the top portion where the crack starts, and it flows downward and it ends at the top portion. It may be some 4 kilometers. You can see in many of the places in Kerala also in 2018, the material has moved up to 4 kilometers downward, the debris material that has been moved. So that is the toe where it stops, is called at the toe, the crown toe, and you can see it is confined by the berm on either side. And we talk about the mass wasting. We are studying from the degree onwards, what are the causative factors like that. And we say that when we take the external factors, you can see the rainfall and earthquakes. These are the 2 major external factors that is influencing the slope failures. Rainfall is a major one that is happening in many of the places. And you see that the major factor that is influencing is rainfall itself, whether it is in the Himalayan region or in the Western Ghat region. You can see that may be considered as a main factor inducing or triggering the landslide and the mass wasting process. And of course, even though earthquake is not a prominent factor in Kerala, but you can see in many of the places in Himalayas and other places, you can see the seismic induced landslides have been formed. And particularly in the Himalayan regions, we have noted disastrous landslides because of the earthquakes and other things. So these 2 can be considered as the triggering factor. But some inherent factors are there on the slope. For example, the slope height. We call that one as the relative relief. That is the lowest from in that particular area to the highest point. And that we call that one as the relative relief. That play a very important role in controlling the landslide activities. Then drainage. So you see that in our studies, we can see that many of the landslides we have seen they are all associated with first order or second order streams. And we can see number of such situations. So that's why we say that these small springs that is developed in hilly regions are very important. We have to conserve these kind of drainages by any coast. Then, of course, lithology. We talk about lithology because as far as Kerala is concerned, we have got a very thin layer that is called the lithomarch. Just below the lateritic layer, the lithomarch, that is just got a different friction angle, a very low friction angle, cohesive strength is very less, and also we see that the plasticity, liquid limit, everything, the engineering properties are low. And so these lithological characteristic and engineering characters are connected, and that also play a tricky factor in many of the landslides in Kerala. Then another geological parameter we have to consider is the joint pattern. And what is the type of joint that is present in an area? What is the attitude of the joint, orientation? In which way it is dipping? What is the slope at which these joints dip? These are all very important factors. So that we have to go there, we have to examine that place itself. Then we have to get the details of this joint pattern, their slope, and other characters. Then comes the material properties. I have mentioned that is the cohesion and friction angle. That is the 2 very important factors that is influencing this mass wasting process. Then, of course, the pore pressure at potential slide surface, because the pressure that is accumulated because of the accumulation of water, because water cannot infiltrate down, and because of that, a pressure is developed at the interface of a relatively weaker rock type, and below you can see a very tough rock. And at the interface, you can see the pore pressure is developed, and that becomes a very important factor in influencing the mass wasting process. Then if you look at the hill ranges of Kerala, you can see the thickness of the overburden. That means many of the debris flows are because of this the overburden thickness. That is very important. Right? It may be 2 to 3 meter thickness of overburden you can see that is resting over the hard rock or highly weathered rocks. So that thickness, if the thickness is more, then you see that the chances of this kind of slope failure and other things, that also becomes high. So these are the inherent factors. We cannot modify these factors. Only thing is that these are all inherent factors present in any slope area. But you see that in Kerala, if you look at many of the landslide series happened in 2018 and 19 or previously, you can see so many anthropogenic factors. On this day of Gandhi Jayanti, we have to talk about that one because anthropogenic activities, the man-made, human-induced factors are very important. The quarrying, because of the quarrying, we don't know how much explosives are used in the blasting, and this may cause or that can act as one of the factors. We cannot say that is the only factor, but that can be one of the factors that can induce the landslides in an area. Similarly, the reservoir-induced seismicity, RIS means the reservoir seems that also is a very important factor in this. Then the land use practices, you can see that the change in the land use practices that also often produces these kinds of debris flows and other things. Then the deforestation, you see that our forest areas are shrinking, no doubt in that one. And a lot of forest fire and other things are happening in different areas. And if you examine many of the landslides happen in the forest areas, that may be related to the degraded forest areas. And that there is a strong relationship between this deforestation and the failures. Then the roads that is coming out, you can see number of roads. You can see the network of roads that is coming in many of these highland regions that also making. These are all man-made activities. That is the place where we can work. We can minimize these kind of man-made, man-made factors can be taken from these among the factors, and that is how we can reduce the chances of the failure. And you can see this is a picture of a Pune landslide, Milan, that is happened in a very important place in Pune, where you can see the Malin in 2014. Pune landslide happened. You see that a village was completely washed because of wiped out because of this landslide happened. You just see the dimension of the landslide happen in our Kerala Western Ghats is, you see that it is the dimension when you compare it is shallower, and also it is limited to a particular area. But here you can see a village is completely taken up. That is also a part of the Western Ghats in Pune, Maharashtra. There it happened. And this is something different. I told you that lithology is a very important factor. You just see the Uttarakhand disaster in 2013. You can see the fragile rocks that is there, how they are dipping. You can see the road is there, the narrow road cutting, and you can see the relative relief. The valley bottom is the lowest point there, and the upper point is at the top of the hillock. And that is the relative relief. That is the most important thing. That has got a very important influence on this one. And also you see that the dip of the strata, the fragility of the strata. In our Western Ghats, Kerala Western Ghats, we don't have this kind of lithological, fragile lithology is not present. Only in lateritic places and where the lithomarg is there, that is where the problem creates. Otherwise, it is not much problem in this area. So lithology is a very important criteria that is influencing this. So in any kind of disaster, whether it is any kind of natural disaster, you see that what we are trying to do is we are trying to reduce the risk. A hazard is there. Landslide is a hazard. So what we are doing is we are trying to reduce the vulnerability. We are trying to reduce the vulnerability, and we used to increase the capacity. Capacity may be the environmental management or awareness program by which we can increase the capacity, knowledge and capacity of the people, the local people and the local environment. and reducing the vulnerability. We can reduce that vulnerable situations like the improper land use practices, improper or unscientific blasting in different areas in high hazardous zones. So thereby we can reduce the vulnerability. So you don't make houses in a high hazardous zone. Thereby we can reduce the vulnerability. So we can reduce the risk by increasing the capacity and by reducing the vulnerability of the environment. So that is very important in any kind of disasters, and even it is applicable to the landslide also. Okay. And when you come to Kerala, you can see that we as a geology people, you see that we can use the term landslide, but you see that we can identify whether it is a debris flow. A debris flow is I can show you the pictures, then you can understand that. The overburden material, the top, the soil, then the highly weathered materials, lateritic materials, everything that you see at the top of the hard rock, that may be flowing down because of the gravity. Then we call that one as a debris flow. That is actually the Uralpadam. But in many cases, it is just landslide. Shila, Malayalathil nammal parayum Shila Tenimal, and the rock may be sliding. And then we have got the slab slide. That is the one that we see in Munnar, but in Wayanad and also in Thrissur, even in Idiki. We have seen number of slab slides associated with the monsoon, southwest monsoon of 2018 and 2019. Then slump, you can see a tongue-shaped. We have textbook language. If you borrow, you can see the tongue-shaped the structure is formed. You can see the very less cohesive material that is slumping down. And in many of the places, you can see the slumping is a very common characteristic. Even along the road, you can see this kind of slumpers, but it is a mini form, but larger slumps are also there. Then rockfall and ground subsidence. And this ground subsidence is it's a very important type of slope failures. And actually, we have to do lot of work on this particular topic, ground subsidence, because it is the vertical movement of the ground downwards. And because of the soil piping is a phenomena that leads to the ground subsidence. So even in Kasaragod and other areas, you can see that lateritic terrains are there. There you can see the soil piping, and in Kozhikode, Idiki, Wayanad, everywhere you can see the frequency of this kind of ground subsidence is increasing. So that is something we have to watch, and we have to give some kind of stress on this kind of subsidence. And this is just to show how the joints control this kind of landslides. You can see this is a major landslide. You can see that it's a small and shallow one. You can see two joint planes. You see that this is a joint plane that is dipping like this. This is another joint plane. This is dipping like this. These two joints intersect, and along the line of intersection, it is dipping. And along this line of intersection, the material is moving down. You can see the big blocks of rocks. And these blocks of rocks move downwards. And this is good enough in a place like Kutikanam or Pyramid, that area. If a block of rock like this falls down, you can see that the entire road can be blocked for 2 or 3 days. So that is happening in many of these. This is called the wedge failure. This is controlled by the joints. And this is what is typically a debris flow. This is one that happened in Pullurampara, that is in Kozhikode. You can see that a number of debris flow, 36 debris flows occurred on one day in Pullurampara. That was in I think it was in 2011 or so, and Pullurampara debris slide within an area of say 2 or 3 square kilometers. 36 landslides happened within an hour. So this is something great, and big type of series of landslides that is concentrated in a particular region in this region. So this is something, and this is the slump. You can see this kind of thing, a smaller one that I have exhibited, and this is seen along the roads, and where you can see, and the bigger one like the Kavalapara or in other regions, bigger one can be seen, and then we call that one as when casualty is there. All these things are very important. When the casualty is the most important. When you can see number of such landslides and landslips and slump are happening. And because there is no casualty, the media is not interested in that one. So that is how it goes on. And the next one, you can see the rock slide that is happening. And along a joint plane, you can along the plane along which the rock is falling down, and this can cause a lot of destruction to the agricultural land and other things in the area. So this is in Idiki and this I have told you about the slab slide in Vatapara. This is in Thrissur district. You see how it happened. Either this would have been a bigger debris flow, but it stopped there. Maybe the factors was not effective for inducing a major landslide. This is actually the cracks that is developed. And if you you see that the height, the relief height difference between the different steps that is developed. Oh, this is something great. And you see that these are all experienced in 2018 and 2009, associated with 2018 and 2019 southwest monsoon. So this kind of slab slides, we call that one as aborted landslides or debris flow. And lucky that it didn't turn to be a bigger debris flow and made casualties. And this is the subsidence. You can see that suddenly the ground has fallen down, and you can see that what really happened in that one. You can see that a well-like structure is formed. And when we examine the different areas, what we could see is that you can see number of holes, pipes are formed in different areas. Not in that area, but maybe the neighboring area. From that area, maybe some connected pipes will be there. That is the natural pipe within the lateritic rock, and through which the material is coming down and just gushing out. You can see tons of material, tons of very loose, fragile plastic material that is coming down. You can see that these are the holes, soil piping, we call that one. And see the material it is very, very fragile plastic material, tons of material. So you can see from underground, this lithomargic clay that is seen at the bottom of the lateritic terrain that is just gushing through the pipes. And it is, whenever it is exposed, you can see it is cumulatively deposited at the site where the pipe is ending. There you can see this kind of thing. So this is a dangerous thing. And you see that many places it is there, and only by what we call the ground penetration GPR survey or something like that, only then we can understand what is happening beneath the earth, say 2 or 3 meters below what is happening, and how the connectivity of the pipes are there. And these are very important things to be investigated, and young researchers can do a very good effort in this kind of studies. And you see now a group of engineers are coming, and we are consulting from Cochin University, from IIT Palakkad. Many people are coming, and they are also very interested because they can suggest some mitigation measures where once geologists can tell the factors that is leading to this kind of subsidence or any other kind of mechanism of the landslides, they can give some kind of solution that is very important. And that is one thing that we find, a gap that we find or miss in Kerala. We have to find solution for that. Now we know how to identify the prone areas. We cannot say that landslide will happen there, but these are all prone areas, we can say. But we cannot say that the landslide will happen at 2 o'clock during June 15th. That we cannot say. But we can say this is prone, and therefore what activities we have to restrict in that area. And these are the things that we have to address when you do and this is simply the rock falling from the top of the hillock when it is very steep slope. And also you see that some rocks are detached rocks will be there, and these are falling on the houses, and that can cause damage to the property and also the life. And this is a very important statistics that we see. You see that 1961 to 2016, how many people are died? Our answer is 295. And when you come to Amburi Thiruvananthapuram, that is covered in, that happened in maybe in earlier, within that period, before 2016, that was considered as the biggest landslide in Kerala, caused maximum the casualties, 38. But you see that 2018, 2019, and 2020, within 3 years, you can see the total. If you add 20 plus 59 plus 12 plus 61, you can see how it is going. The frequency, the intensity of the landslides and the slope failures are increasing. I will say that slope failures are increasing. So we have to give attention to this very important phenomena, how we can mitigate, because the frequency is increasing, our climate is changing, because the rainfall is concentrated in a particular area. Even Wayanad, Kavalapara, and other area, or what we call that area, I have mentioned in Kozhikode, that is the name of Puliyambara. You can see rainfall is concentrated, it is falling within a, say, 2 kilometers or 3 kilometers area. The intensity is very high. And this kind of rainfall is the main villain. All the other factors are there, but you see that is triggering many of the landslides in Kerala. So this will increase. If the rainfall pattern is changing and the rainfall is concentrating in some of the areas like this, then you see definitely the number of landslides will be increasing in the future years also, and you see the people are also in danger in the future years. This is what we call the Kavalapara area. The first, this one, you can see that it's a little, the photo is a little bit flattened. You can see the disaster that happened in this one, Pettumudi in Munnar, near Munnar. You can see the settlements at the base of this hillock was completely destroyed. And you can see that there is a tea garden, you can see. And the tea garden, you know that tea garden means they are all, they are having shallow roots. And you can see number of the tea trees. And the shallow trees, you can see the roots of these trees that will form a network. And that will form a sheet at the base, say 50 meters or 1 meter. 1 meter maybe much bigger. The value is say 50 meter or something like that. That will form a sheet all over the hillock. You can see a sheet that is spread at 50 meters or 1 meter below this one. So that is a shallow root. And you see that form an interface actually. The characteristic of the soil, the texture of the soil, because of this shallow rooted network that you see as a mesh-like thing that is formed, the entire the hillock. When you see that area, you see that it is very calm, beautiful. And it is in the figure, it is in the photograph, it is not seen. The slope is also much greater when you go to the upper side. In the forest area, beyond this T part, if you go to the upstream side, you can see the forest with 20-25 degree slope. And this is a very important thing because the water that is percolating down, that cannot move downwards much because the heavy rainfall. If you look at the rainfall in that area, now this is the thing you can see in the imagery. If you look at, you can see the evergreen forest at the top. Then you will get the tea trees. Then you can see the settlements. You can see this picture from this. So this is the steep area. Then coming to the slope is lowering, and then coming to the settlements. Okay, this is the rocky area that you get. No vegetation is here. Actually, this is the forest area, and this is the tree area. Tea garden area. Okay, so next picture, if you look at, you can see that this is the rainfall that you get. You see that your total, if you go, that comes about 600 meters within 4 days, 5 days. You can see that the rainfall happened in that area is 600 millimeter. That means that is the rainfall that we get in a month in many of the districts, 600 millimeter rainfall. So this is you can see the intense, copious rainfall that is falling in that particular area for 4 to 5 days. So rainfall is the factor. Of course, the other factors are also there, but you see that the rainfall is the main triggering factor in that area. We cannot blame other prominent factors, but you can identify that is the main factor that is inducing it. And coming to this one, and I have drawn the illustration there. You can see the forest area at the top. Then you can see the Taylor Totem, that is the tea garden, and then coming and here you can see the top part. You can see the shallow roots of the trees, tea garden, and you can see that here you can see that will form the meshwork, and that is up to say 50 meter or 1 meter, that will be the maximum depth. And you can see actually the slope failure happened in this region. Actually, this happened in this region, that region. I can see this is the region where it happened, in the tea garden. And when the top portion, actually when the started failure, you can see the entire, that increased to the extended to the forest area, and the forest also that fall down. And then it became a major landslide in this area. And you can see that, you can see the water, 600 millimeter rain for 5 days. The water is percolating down, the laterite is there, the soil is there, the water is percolating down, water is flowing like this. And below this, you can see this is the hard rock that you get. The water cannot move downward. And you see that at the interface, because the water cannot move down, you see that a pore pressure is developed. And this pore pressure, actually, you can see that is making a buoying force, actually, that will try to push the whole thing upward. That's why I say that this is the focus point. There you can see the buoying force develop, and because of the water, the shearing stress, shearing stress that reduced and that induced the failure. So this is how we can say the mechanism of the landslide, the slope failure. I will call that one as the slope failure in the Petimodi. Okay. And this is the thing that we see in many of the students may be interested in this, because you see that this is a slope. You can see a columnar block here. You can see there are the weight. This is the weight that is making. So this is stable here at this slope, at this particular slope angle. This material is stable. There are two forces acting. The weight. This weight can be resolved into two. One is W sine theta, that is the force parallel to the slide's surface, and this is W cos theta that will try to fix the material there. So when W cos theta is the resistive force, and W sine theta is the force that is driving force. When the driving force is greater compared to the resistive force, you can see the whole thing will come down. This is the simple mechanism. And how this driving force increase, and that is, that can be due to the rainfall. It can be due to the slope remains the same. Only if you interfere there, and if you interfere there and make slope modification, then the slope will change. Otherwise, the slope will remain there. So other factors, unscientific practices, land use practices, that will reduce the W sine theta of this one. Okay. And this is the Navier-Coulomb failure criteria. That is the fundamental in everything. I'm not going much detail about it. And this is what you call in a lateritic terrain. If you look at W sine theta is equal to S plus W cos theta tan phi. That means S is the one that is cohesive strength of the material that will try to fix that material there. Theta is the potential of the slide surface. Friction is the angle. I have already said you the material property, the friction angle, that is very important. So a slope becomes stable when W sine theta is equal to S plus W cos theta plus tan phi. When there is pore water pressure, U, what happens? You can see in the equation, W sine theta, S plus W cos theta minus U, that is the pore pressure. You can see that the whole thing, the shearing stress is reduced, and you see that the W sine theta, that will be increased, and the material, because of there is a hydraulic head is developed there, and that will induce the pore pressure, and the whole thing will slide down. And this is a picture in which how the man-made changes are influencing the slump or the other thing. You can see the vertical slopes, and you see that can you see the white patches there? These white patches are clay. You can see that we have examined that. We have done mineralogy of this one, and we have found that it is mainly kyolinite, and little montmorillonite and chlorite are present here. And this is the clay content in that one. And we have done and if you look at, you can see that at the top there is the soil, and then comes the laterite, then comes the lithomarch, and this part is rich in lithomarch. And this lithomarch part, because water is infiltrating down because of the rainfall, the water cannot move downward because lithomarch is porous, but it's not permeable like the laterite. So when heavy rainfall is there, this water that will form a spring here. Sometimes the water will move, more water comes, it cannot move downwards, and then a pore pressure develops, the whole thing will collapse. And this is the one that when we visited the field in 1994, way back, you can see then landslide was not a problem for many of our studies. Then you see that you can see this flour rice mill there, and you can see that it was there in 94. In 95, we already cautioned the people, you cannot cut the place like this, vertical cut, and make houses. So many houses are present at this part, and you can see that. And 95, after the monsoon, when we visited that place, you can see the entire this rice mill was completely destroyed, and nothing was there. And luckily, nobody was there because it was noon interval, and nobody was there. Otherwise, many people would have been killed. This is the typical unscientific type of land use practice, what we call, for building and construction, road construction, and everything. And this I have put that one in a figure. It is not very clear. Laterite, you can see this is the lithomarch layer, and where you see that a spring is developed. This is the place where the slip happens. So this much part every year, cyclically, every year you can see that this part is falling down because of the pore pressure, and this is the lithomarch. Okay. And this is the one that we see in Tamil Nadu, Kunur, and you can see how the things have been changed, and you can see that very wrong land use practices, number of houses, very steep slopes, and you see that what they have made is they have cut the top for road construction and refilling the road. They have made that one, and the southwest monsoon came, the whole thing was destroyed, and the road was completely broken, and the things like that. So we have seen some of the slides. You remember, one is how the building construction is taking place, how the land use practices. These are all very important things. Now we see that another place. This is a forest area, and many people will argue that, oh, you are saying that no landslide will have the landslide will happen, even the landslide have happened in forest area. Of course, right. When you examine Agamala, this is in Thrissur area in 2004. This is a typical area. That is why I have taken this photograph. And we could see that this area was completely, it was degraded forest area. That forms the crown of the debris flow. And you see that from there, the debris flow initiated, and it flowed down. And you see that number of settlements are there, even though it is a forest area. You can see at the bottom, the dwellings are there, and you see that we caution the Tahsildar that this is very dangerous, and you have to evacuate the people from there. And because you can see that the next picture, you can see new cracks have been developed. These new cracks may be 1 meter, 1.5 meter. We can put some stick into this one, and 1.5 meter deep, maybe more than that. And you can see that these cracks have been developed. And when rainfall is there, the water can percolate down, and you see that it can open for a new landslide and debris flow situation. So this is a very important thing. And we have evacuated the people from the base area of this region. And now you see that that is how we mitigate the effect of this landslide. Again, another one in forest area. This is the road connecting Kochi and Madurai, a very important highway for us. And you see that this is the Chiapara landslip, what we call. And you see that, do you know how it happened? You see that rainfall was there. It's a forest area, reserve forest area on the top. And you see that it initiated because of the rainfall. And you see that many areas you can see where the trees are fell, and from there the landslip started. So this is how in many of the forest areas you can see this kind of landslides. You can see. So coming to this picture, you can see that if it is a rubber plantation or a tea plantation, and earlier you can see that when you take a statistics in 2012, when we studied the landslides in Kerala, we can have the statistics. It was like that. 60% or 65% of the landslides in Kerala is happening in rubber estate. That was the statement that we have made. Now we have to change that. But here you can see that why that happened in rubber estates and tea estate earlier. Because you see that the shallow roots, you can see the shallow roots. These shallow roots, green one, that is not going deep. But you can see if it is a forest tree, the tree roots are moving downwards. It is just vaulting the upper. This is called the overburden. You can see the overburden. The students can see this one. This is called the overburden. This is the hard rock. Over this, you will get the overburden. So that part, you can see that this part is the place where you can see the rain is falling, infiltrating, and you can see that the water comes down. And again, at this point, you see that the water cannot move downward because it is hard rock. Therefore, water pressure develops and the whole thing. That's why you see that in shallow rooted, wherever there is shallow rooted trees, along the steep slopes, I have to add very important point, that is in steep slopes, not a gentle slope. That is, steep slope means greater than 25 degrees slope. Then we call, when in such places, this wrong land use practices, we are felling all the trees and we are going for rubber or tea estate. We must be very vigilant, and in such situation we must protect the channels, that is we call the hollows, must be protected, and the water must flow freely along these hollows. This is the one that is Amburi in rubber estate. Earlier we considered 2001. Okay, 2001 this happened, and many people, 38 people died in this debris flow in rubber estate. That was considered as the biggest one earlier. Now you see that was because of the contour bunding, the land management practices, unscientific land management practices, that actually caused. But of course, rainfall was also very high, and that caused the Amburi debris flow in 2001. And this is another one. You can see how the engineering structures are made. You can see this is repeated in Wayanad also in 2018. When we visited the places in the same engineering college, Wayanad, if you look at there, if you go government engineering college, the same thing happened. That is, we call that one wrong engineering practice, without the consultation of a geologist, a hydrogeologist. That is very important, because what is the water table in that area? Here you can see what they have made is a beautiful building, Government College Munnar, in August 25, because number of landslides happened in and around Munnar region, and along with that this happened. You can see the let's say lateritic crust, the whole thing moved. What they made is they excavated the area, then they leveled that area for a playground area. At the top you can see this one. This they made for playground, some basketball court or something like that. So by making this court or the ground, what happened is the natural flow of the river is prevented, and you see that actually caused the free flow is prevented there. Water percolated down, and you see that the infiltration rate was very high. It infiltrated, and you see that the whole thing slipped down. And if you go there, you can see that the lowest, the base floor of the government college Munnar is completely filled with the base floor. The ground floor is completely filled with clay and the lateritic material. So this is a wrong engineering practice. The same thing happened in the present. Now they have started another college. There also the same thing happened, but the gravity was lesser, and also in Wayanad Engineering College. So we are not carrying this kind of construction without consulting geologists. They are making this kind of construction. This is our Puthumala in Wayanad. There you can see the before and the present situation that came in many of the media. You can see that we have already made the map for the landslide hazard zonation map. There you can see the high hazardous zones, moderate hazardous zones. And you see that this Puthumala landslide happened very close to the moderate hazardous zone. And you see that this is the moderate hazardous zone. And very close to that one is the high hazardous zone, very red one. And so you see that what a geologist can do is, it is only 1:25,000 scale or 1:50,000 scale. What we are making is this landslide hazard zonation map. Now, what we are asking is to prevent the quarry operation or blasting activities in the high hazardous zones. We are not giving sanction to the quarries in high hazardous zones. And also, we are stopping all the quarry blasting and other things in the moderate hazardous zones. So that is actually a precautionary measure that we are taking after the many landslide events that happened. And this is the one landslide event in Wayanad. You see, it's a very interesting thing. We know that we have identified, you can see this is the hazard zonation map already made. High hazardous zone, this is a scale is 1:, bigger scale, and therefore I don't know, you may not be able to understand much, but you can see the red pockets means we have already identified these are high hazardous zones. They are hazardous. Anytime the landslide can happen if rainfall extends. And then low hazardous zone and moderate hazardous zone, it is given. And when we plotted all the landslides and the slope, mud flows, mud slips, subsidence, everything mapped in the hazardous zonation map, and you can see that many of the slips and other thing that is falling out of this high hazardous zone and the moderate hazardous zone. And so this is a thing that must show some interest, because we are constructing houses, we are constructing roads, but it is wrongly constructed. We are making cut cliffs, steep cut cliffs, and making a house just below that one at the base of the cut cliff. So this is something that will invite landslides and subsidences and other kind of things. So we cannot promote that kind of thing. So we have to some kind of regulations for these kind of aspects. See this. This is just to show. You see that the road buffer. You can see the road that is connectivity of in the Wayanad region. You see where it is falling. Majority are associated with roads, road cuttings, or the cuttings. So this is a clear indication that the wrong land use practices, how it is promoting this kind of things. So it is very close to the road cuttings. So presently we have got different methods. Already we have said that this is the methodology that we use the Survey of India topo sheet. We make thematic map like the slope with different angles, say 10 to 20, 20 to like that, different slope, relative relief, aspect, curvature, drainage, density, drainage frequency, land use, road buffer, and drainage buffer. These are all factors that we consider when we take the thematic map. And we give a numerical weightage called landslide susceptibility values. Or for each parameter, we are giving that one. And all the factors were taken to the analyst. Extension RGAS is used and finally classified into stable, moderately stable, and unstable, highly unstable. So this is how we give. For slope, we are giving a weightage of 30. relative lift 10, aspect 5, curvature 5. So this is in discussion with so many papers and other things. And it will be, this is how we give weightage for the different factors that is inducing the landslide. So we prepare the thematic map, overlay that one, and we find the landslide happened in the different zones. And finally, we make the landslide susceptibility index. And so that will give you the next part. And that will give you an idea about the moderate hazardous zone, less hazardous zone, like that. And that is actually, that is very good. But what I am saying is that as a geologist, this is not enough for a detailed study. We must go beyond that. So that must be useful for the public. So if you make a lot of maps, 1:25,000 scale, and telling the people like that, the panchayat cannot use that. And ultimately, the beneficiaries of the panchayat and the people living in a panchayat. For example, in Karuvarakunda or in Malappuram, many places are there. So you can see how we can make use of these maps. That is very important. So what I am suggesting is that we can use geometrical analysis. We have to 1:2000, or that may be the scale. You can select some areas. We have already identified the critical areas, and we find which are the risky areas. We cannot map all the areas because 1:2000, 1:3000 area, geotechnical analysis, geological and geotechnical analysis means that it's not very easy. It's not very easy job. So what we can do is we can select the risky areas where the people, where the settlements are there. There you can see the risky areas. Then we can go for this geometrical analysis and geotechnical analysis. You see that the wedge failure, you see that this can be applied to the, because Tamarisheri Churam, if you take, or the Kottayam Kumli road, many ghat roads are there, even the Madurai Kochi road. You can see the many ghat roads, you can see the frequency of the land slips are increasing. So we can find what are the type of failures that can happen with the use of three important one is the joint. What is the attitude of the joint? Then what is the lithologic characteristics? Then the cohesion and friction angle of the material that we have to do in a geotechnical lab. If we have got all these kind of factors, we can find whether it is prone to wedge failure or a plane failure or toppling failure or something like that. So the trend of so how we can use that one? I am not, because it becomes a class if I go for this one. So I will just show you. This is how it is not applicable everywhere, but some of the terrains, when there is a cliff section, if you can see that, this is a place where this is the slope of the, this is the slope. This is the slope. You can see the slope. You can see H. Can you hill slope? HS is marked. This is the that is a broken line. This forms the hill slope. The altitude of the hill slope, broken line. Then you can see this is the friction angle that we have plotted, because the friction angle is having. This is the plotted in this one. That is circular one. This is the one circular one. And you can see this slope, hill slope, that is the broken line, and the friction angle make a shaded area. Okay, can you see? Can you see this shaded area? Okay. So this crescent-shaped area, you can see there are two joints. I am plotting two joints, J3, and the 2 points are J3 and J1. They are intersecting, and you can see that is falling in the crescent-shaped area. Then we say that because of the Hawk and Bray method, the geometrical analysis, we say that wedge failure can happen there. That is a type of big slides that can initiate slides. This can be very well, we can apply this one in along the road cuttings. But in some of the areas, we can use this one. We find the joint planes and other thing. What type of, this means that the fact it can be when the rainfall is there, you can see that the intersection can move towards lower down, and this can cause failure. I say that this is a prone area. Therefore, we can select each area and we can go for geometric analysis and also the geotechnical analysis. You can find the factor of safety of that area. This will be meaningful and useful to the public and can be used for the panchayat. And some of the areas, I have shown you the other one, it is applicable to hard rock terrains or the highly weathered rocks. This is the one that is applicable to the cliff with, say, what you call the laterite or earthen slope is there. We use the Fellinius method or the Bishop's method. You find the slope, you find the geotechnical properties, and you can draw trial circles. You can find the slip failure surface. This is the slip failure surface that is dotted, along which the cliff can failure. This can also be used in some of the slopes. So depending upon the slope, we have to use different techniques, and that will be useful for this. Is how the Bishop method and Fellinius method is going to be combined, and you can find the factor of safety, whether it is 1 or 1.5 or less than 1, and that will be useful to tell the people what are the type of the steps that we have to take this one. So these are some of the equations related to that. I am not going because it is 12:01. That is the time here, and so 10 minutes more. And you see that anthropogenic factors, almost coming to the closure part, you see that the top part cutting, we have seen in Munnar, the Kunu, we have seen that one. Top cutting is a very important problem. Man-made intervention, blockage of drains for in the steep slopes, and we can go for Madakuri and all, rainwater pits and other thing in a general slope, but we cannot be practiced in a steep slope that is very dangerous. And also for the soil conservation and other thing, you can see if you look at this, if you go and examine the areas, you can see many of the first order streams or the hollows are blocked. And if you do, you re-examine 1972 the scenario of the Kavalapara region, you can see that there were 2 streams there, hollows, that is seasonal, that becomes active only during the monsoon period. These 2 streams are not there. It is blocked. It is filled with. It is packed with the houses and other things. So these kind of things we are knowingly or unknowingly doing that, and that is making problems for us. Then land use practices we have already discussed. Artificial loading of water on slope, quarrying and blasting, deforestation. These another very important factors. We call that the man-made factors that is affecting that. And what are the management strategies? That is very important. And whatever that we are doing, a geologist is doing, that must be meaningful, and that must be useful to the society. And we can find geologically and geotechnically which are the highly vulnerable areas. What we have to do there, we have to do some spatial planning. And you know that the Gargill committee report and what he was saying like that, the professor was saying that the planning, spatial planning and other thing. In which area we can go for construction, which area we can go for plantation, which area we can go for other factories and other things. So that is very important in that one. So we have to give building codes. We cannot make a house, the type of house that we can make in a middle land, that we cannot build on a slopey terrain. So there must be restriction. Why not collector, I think Keshavendra Kumar or something, district collector, introduce the building codes there. How much the only single-story building can be constructed in a gradient with 10 to 15 degree or like that? What type of precautions that you have to take there? What type of the sanitation is also very important, the latrine and other things, the water that is draining out. What type of the suggestions that we can give and what type of precautions that we can do, that is very, very important. So the spatial planning, building codes in high hill ranges are very important. And people must know, the panchayat must know. Awareness is very important. The B people, the students of geology or environmental science, they must go to the field, and when we started in 90s, when we go to the field and make awareness classes, conduct awareness classes, people will try to slash us. But now you can see their mindset has changed. Now they give ear to what the scientists are saying or academicians are saying, and now they can understand the things. But that was not the situation previously. Only 2018 and 2019 floods and the disasters that opened the eyes of the people in the hill ranges. Then the construction of building close minor drainage hollows edge of previously failed area. And you see that once an area is failed, whether it is debris flow or land subsidence happened in that area, you never go and construct house in that area, because we don't know the causative factor has been removed in that area. So that is very important. So very close to a drainage, or we are filling the drainage channel and making houses, obstructing the drainage, that can invite landslides and debris flow. This has happened in Kunchitani in 2013 in Idukki district. Number of big buildings have been constructed across these, the hollows have been totally wiped away because of the landslides. Then afforestation, a very important thing, with suitable species in upper forest areas. You can find the forest department can conduct a survey. They can use the NSS people or other people, and they can say which are the areas that is degraded forest, where the settlements are there. They need not go and find all the degraded forest area, but where the settlements are there, where there is risk is there you can find the problems, and they can go for this kind of things. So afforestation in the selected areas that can do. Regulation of traffic during monsoon period along the ghat roads. This Tamarasheri road or any other ghat roads, if you take, and previously there was no way to stop the traffic along these kind of roads. Now we have got, when there is heavy rainfall, we use the traffic police to block the roads, and entry is permitted, terminated for the passengers through this road. So the regulation of truck, because a heavy truck, when it is closed, when there is rainfall, continuous rainfall. I'm not the usual, the scanty rainfall, but continuous rainfall for 2 or 3 days happens in a hilly region. Even a truck that is moving, that can make vibration, and the moment the vibration caused by a heavy truck, even that can induce landslide. So that is very important. Then what we are stressing is the micro level studies, the geological and geotechnical studies. Need studies using GPR, that is very important. Only thing is that our some studies have conducted. Shankar has done some excellent work in this soil piping and these things, but we need more. And what is the solution for that? People are looking for that. What type of solution that we can? That is very important. And for that, we have to take some plots, and we have to go for experimental plots and go for geotextiles or other kind of things, how it can apply to prevent this kind of failure. That is very. Then engineering structures like retaining wall, geotextiles also can be used with vetiver, ramacham, vetiver that can be used. Or we can use some other thing. We can go for an experiment. We can consult with the botanist and say what are the other things, other kind of species, tree species that we can grow in that area, so that the soil, the overburden material can be firmly fixed to the substratum. So that type of experimental things have to go on, and education on disaster and risk, that is also very important in preventing any kind of disaster. And these are very important in managing a disaster. I have already said that we cannot prevent a landslide. Landslide will happen whenever there is rainfall, continuous rainfall of this magnitude happens. When there is earthquake of big magnitude happens, and along with that rainfall is there, landslide can happen. We cannot prevent that. But we can identify certain areas, say that these are some of the areas where it is vulnerable, risky areas. We cannot go for developmental activities. We cannot go for the major mega projects there. That we can do. This is what we require in that. So there is no other solution for that. And we can reduce the risk by adopting management strategies, and we can reduce the risk. So, and you see that the hazard, what is the difference between a hazard and a disaster? We say that it's a landslide hazard, means the area is prone to landslide hazard. That doesn't mean that landslide has happened in that area. A disaster means when the landslide even takes place, the loss of life and property, then we call it as a disaster. So in order to prevent the hazard, we can identify the hazardous area. You go for the preparedness plan, like the scientific studies, the mitigation measures, engineering and non-engineering measures that we can take. And all these kind of things can reduce the vulnerability, and we can go for a better land use practices. And that is the most important needed in this situation, because the flood and the extreme events are happening. These extreme events are the most important thing. When we talk about the flood and landslide, you see that we have to go beyond that. That is the climate change, and whatever things that we can try to evolve or evolve the models for mitigating that one. That is very important in this one. So that is what I want to share with you, and thank you very much. I particularly thank all my friends for giving me an opportunity. And you see that any kind of discussion we can go for. This 12:15. I'm stopping here. 12. Okay.
Thank you, sir.
Okay.
And sir, there are a few questions from the side of the participants.
Okay.
So I would like to invite Sri Kavya B. Krishnan to discuss in part.
Please, Kavya.
Thank you, sir. Thank you for your enlightening words, sir. Before we conclude today's session, we have few questions from the participants. Sir, with your permission, I am moving to the first question. Sir, what is the slope in the Kavallapara slide area?
What is the?
What is the slope in the Kavallapara slide area?
It is greater than 25 degree. Kavallapara,
Okay.
even Putumala, all these areas, it is greater than 25 degree at the top part.
Okay. Thank you, sir. Moving to the next question. Is there any notifications or rules from Kerala government for micro and macro level land utilization strategy?
A very good question. That you see that we are raising this issue before the government. We have to go for, particularly go to the high ranges like the Wayanad or Munnar and other areas. You see that we have to go for this kind of micro level planning. And the local self-government in Kerala have acted, of course, in 2019, they have acted rightly, because they have given some, allocated some project money for identifying the hazardous zones or the zones that is prone to natural hazards in that panchayat. So they have allocated money for that one. So what type of mitigation measures or to identify the prone areas, for that they have put some money for that. Earlier, it was not like that. The entire disasters that was addressed by the revenue department earlier. But now in Kerala, we are becoming a model, and we are saying that the panchayat can play an important role. Even when a disaster happens, the ward level committee can involve in the first aid and other mitigation the post landslide events also they can interfere. So that type of thing is important. And because we have now, at present moment, we have got that kind of local self-government is intervening in this issue rightly. But you see that we have to go, I think we have to go much faster in this one, because you see that every year this kind of extreme events are happening. So what we have to do that.
Thank you, sir. So we have another question. How can we control debris flow in future?
Yes. So we know that debris flow, that is a mitigation. What I am meaning is mitigation. We cannot only, we can find, we have already discussed some of the land use practices. A debris flow happens when the factors like the slope or some other man-made factors, when that exceeds, you can see that the debris flow occurs. And the triggering factor may be the rainfall. So we can prevent that one only by not preventing, mitigating that one. Once you know that it is a hazardous zone, we can identify that. I have told you, this is a hazardous zone. So once you identify this one, we can say that we can evacuate the people from that region when there is when the rainfall is higher. We can find the threshold level of rainfall in that area. What is the level of the threshold level of water? I mean rainfall, and when it exceeds that amount, we can give warning to the people and evacuate the people from that region. Then another thing is that we cannot go for the settlement or other kind of building construction in such areas when it is highly hazardous. We have to restrict that type of construction and building. That is again another important thing there. So that type of activities we have to regulate in such zone if it is highly hazardous. Then only we can mitigate that one. Okay, so mitigation is the important thing. We cannot prevent. That is a very important. We cannot prevent, but we can mitigate the effect. Like that.
Thank you, sir. Moving to
Just a minute, Kavya. Just a minute.
yes, sir. Sure, sir.
Sri Kumar, sir.
Yes, sir. Yes.
Sir, I just have one question.
Yes.
Sir, you have done a lot of work related to landslide in Kerala.
Yes.
Sir, have you used this inverse velocity method for slope failure prediction in Kerala?
No, sir. We haven't. No. Stop. Can you?
Inverse velocity method used for slope failure prediction.
No, we haven't used.
Okay.
We haven't used.
Okay. I think in other parts of India, they have they are using this inverse velocity method for predicting slope failure. I think so, isn't it?
No, we haven't used in Kerala. We haven't used that. Such investigation was not carried out. But we have done some GPR work for to find the subsidence and other by the Center for Earthquake Studies.
Okay, sir. Thank you, sir. Thank you very much for your very informative talk. And over to Kavya.
Okay, thank you, sir. Sir, we have some more questions to be answered.
Okay, please. Okay.
Sir, is there any specific data on geotechnical and geological studies conducted in the landslide area in Kerala?
Yes. We have got so many studies related to geological and geotechnical studies on landslide areas. University of Kerala has done, our department has done, and SES has done. Many papers are there, but it is limited in number. Mostly most of the studies are in other aspects, but we have got some papers related to the geological and geotechnical studies.
Okay, thank you, sir. Sir, another question is there any possibility of modifying the slope geometry to prevent landslides?
Slope geometry. Yes. What we can do is we can reduce the slope. You might have seen in many of these some of the areas in rock cut cliffs and other things. They have reduced the slope. The gradient can be reduced, or sometimes the benches can be made. Benches. I mean, you can find the cohesion and friction angle of the material, and you can see what is the width of the bench, height of the bench that can given in that. For that, we can use the Bishop analysis or the Fellinius method, and you can find the slip, where is the slip circle is touching, and you can decide what is the width and the height of the bench that we can provide in that area. So by changing this morphological features, morphometry, we can go for the minimizing the risk of landslides.
Thank you, sir. We have a lot more questions, but just by asking one more question, we would end this question answer session.
Okay.
So moving to the last question. What is the slope angle which has to be maintained in the scarp areas of hilly terrains to avoid a landslide?
No, we are saying that whenever the slope is greater than 25 degree, roughly we can say 25 degree, then such areas are prone to landslides or any kind of mass movements if it is greater than 25 degree. And 25 to 30, that means that is the area that is very conducive for the landslides to happen. That is what our studies show. Most of them are happening in such areas. Because when the slope is greater, say 40 degree, then you see that overburden is not there. But if it is 25 to 30, then you can see the thick overburden is there, 2 meter, 3 meter overburden is there. Therefore, water can percolate and it is oversaturated, pore pressure develop, the whole thing slip down. But if the slope is greater, then you see that there is no overburden and the risk is also reduced there.
Thank you so much, sir. Moving on to the duty assigned to me, I must say it gives me immense gratification in delivering the vote of thanks to our renowned speaker for today's session, Dr. S. Kumar, who shared his valuable time in explaining about the resilience and sustainability in management of the slope failures in the hill ranges of Kerala. On behalf of GEMS Arts and Science College, the entire webinar organizing fraternity, and on my own behalf, I extend my gratitude to you, sir, for gracing this occasion and sharing your new findings with us. We are highly inspired by your great words, sir. I also express my sincere thanks to all the dignitaries, teaching and student communities who attended today's session. Thank you, everyone, and have a nice day.
Thank you, GK sir, and all the viewers, and thank you very much, administrator.
Thank you, sir. Thank you.
Thank you very much. Thank you very much.
Thank you, sir. Thanks. So we are
Thank you, everyone.
Dear participants, your certification link is on the chatter box. Okay, so please go through for it.